Why, hello there, everybody. Welcome to Adamcast IRL. It's one of those special days where I have some awesome guests on the show. We're going to be talking about the future of space, and we actually had, we had some other people from the Gateway Foundation, talking about basically a space hotel, the Voyager platform, and it's going to be, it is the future. We're going to have operations in space sooner than I honestly thought, maybe 2 years ago. Now that I'm learning more and more, it's like, really, it's happening. And we were talking before about the construction of it. And I have two more experts with me today. Welcome to the show. We have Tim Alatorre and Tom Spilker. Welcome to the show, gentlemen.
Yeah, thanks,
Thank
Adam.
Of course, of course. Well, why don't you introduce yourselves? Tim, I will give you the camera first, and you can tell us about yourself.
Yeah, thanks. I'm Tim Alatorre. I'm the COO and interim CFO for Orbital Assembly Corporation. I'm also the VP of Business Administration and the VP of Habitation Architecture Design. So we're still relatively small, so we wear lots of hats. But I'm a licensed architect. I have a national architecture certificate and licensed in a number of states. I'm an entrepreneur, businessman. I've been running businesses for a number of years. So this is the next step, space business.
Space business.
Yeah.
Yeah, it is. It's the next step. I agree. And Tom, how about you?
Yeah, hi, I'm Tom Spilker. I spent about 20 years working at JPL, and I was kind of an odd bird at JPL. I was both a scientist and an engineer, which there aren't too many of those at JPL, but that headed me towards what they call spaceflight mission architecture. And for about the last half of my time there at JPL, I was a spaceflight mission architect working on various advanced mission concepts to all over the solar system. Planetary things, not human oriented, but I'm making that transition to human orientation with Orbital Assembly Corporation. I'm the vice president for engineering and for space systems architecture design, and have been having a good time with a really great team on Orbital Assembly, putting together the steps leading to Voyager Station and then beyond. Before I came to JPL, I spent 6 years in the petroleum industry, but when Voyager went by Jupiter, the first Voyager went by Jupiter, it reminded me that I'm not supposed to be looking that way. I'm supposed to be looking that way. And
Yeah.
so I went back to school, went to Stanford, got my PhD there in radio science. And it was in the electrical engineering department there. So I got a combination of engineering and science from Stanford, and have kept in touch with both of those since. It's really been a satisfying career, and I'm really happy to be with the Orbital Assembly team working on Voyager Station and the steps leading up to it.
That's awesome. Man, I'm really excited personally about the whole Orbital Assembly group. You know, there's a question that's been on my mind ever since the other side of the team was on my show. When is the hotel going to be finished? I know, obviously, I'm jumping ahead of things. And how do I become one of the first guests? I mean, you guys have been on my show. I feel like it's only fair that, I get some sort of in, right? No? Anything?
Yeah. So it'll be finished when it's finished. I guess that's the.
Oh, you
the answer.
realist, you.
Yeah. I mean, we're moving as fast as we possibly can, right? I mean, the limitation to anything like of the scale we're wanting to do comes down to money,
Of
and
course.
even if we had unlimited funds, which doesn't really happen, there is there's milestones and engineering that has to be done. We were talking with one of the big launch providers this last week, trying to get set up so we can start to do our first launches of equipment into orbit. And there's 18-month lead times just on launches right now. So
Wow.
we're constrained just by finances, manpower, and then getting stuff on the orbit.
The manpower and the interactions among the manpower, and I should say person power, is really important. If you have a task that takes 50 engineers 100 days to complete, If you have 5,000 engineers, does that mean you can do it in one day? Well, no, it doesn't work that way. So
Right.
there will be I was going to say there's an optimum size for the workforce to get things done quickly. If you go beyond that, you start having communications problems and so on, and it can actually slow things down.
Yeah,
Yeah,
they
we
might
do
actually
we
make
do have a
mistakes.
roadmap. We do have a roadmap to get Voyager Station done and operational within the next decade. Uh,
Wow.
right now, we're actually in fabrication right now for a ground-based demonstrator machine that's going to be proving our truss assembly methodology.
Right.
And there's delays and everything. We were hoping to have that demonstration happening this week, but now it's looking like it's probably going to be February, first week of February.
Is that
But
Star?
so that's called the D Star. Yeah,
D
that's going
Star,
to
right.
be our
Okay.
demonstration station truss assembly robot, and we're going to build 90 meters of truss in 90 minutes. Is
Oh, wow.
what we're going to demonstrate. And we've already started engineering and design on the P Star, which is our gravity, or I'm sorry, our in orbit demonstrator of this truss technology. And I know Jeff and John on the show last time they were talking about gravity ring, and so
Yep.
we're hoping to have that. Optimistically, 2022 we would be launching that, and that's talking with launch providers. That's what we're trying to set up is getting that on a rocket.
And that
And
gravity ring is just proving that the system would work for the hotel, correct? If I remember correctly.
yeah, so there's a lot of things that we want to demonstrate and really to reduce risk for our investors. So that way, before we go to the full scale Voyager station, we know that we can deal with perturbations and Tom actually explains all the things we want to. Here, Tom, why don't you tackle what are we trying to prove with gravity ring? Because you explain it
Sure.
better than I do.
The first and really important thing is to prove that the P Star works, and that
Right.
it can indeed build a circular truss the way we envision it, and in a fairly short time. Um, Once we get that truss built, of course, we're making it a spacecraft, not just a ring of aluminum hanging out in
Right.
space there. So we're going to be putting propulsion systems on it, putting communication systems on it. We'll be able to spin it up and rotate it just like we would the Voyager station, and test, does our spin up process work properly and get us a nicely stable rotating ring, which we can't see any reason right now that that wouldn't happen, but we want to test it and make sure. And then once we get it rotating, there are all kinds of tests we want to do with needing to control the attitude. This rotating station, for instance, Voyager station, we're wanting to put in a sun synchronous orbit and point one side of it at the sun all the time. Well, if you're going around the sun, if let's see, this is the sun, and here's Voyager station, and it's going around the sun. If you don't turn the station at all, you start out pointing at the sun, and then 180 days later, you're pointing directly away from the sun. So you're
Right.
needing, and let me see if I can do this. Okay, there's the station. It needs to point as it rotates around the sun, continue to pointing at the sun, and that means
Yeah.
precession of this rotating device. Well, you'll need to precess about a degree per day, maybe not once every day, maybe every week you'd turn about 7 degrees or something like that. But you need to demonstrate that you can control that precession. And this is one of the things we definitely want to demonstrate with the gravity ring, that our procedures for controlling precession and the pointing of this rotating device work as we expect them to work. And the
Yeah.
hardware interactions are what we expect. There are also things that you can do when you're doing those precessions. If you don't burn the thrusters properly, you can induce what's called nutation in this rotating device. And that is kind of, if you look at all of the fingers and thumbs, and around here is the outside of the station. As that's rotating, if you do certain things to it, you can make it wobble. And
Ah.
we're going to be testing what kind of thrusting procedures prevent that wobble when you're trying to precess. We'll be testing structural elements. when we go in and out of eclipse, and as the pointing with respect to the sun changes, certain parts will be heated differently than other parts. What does that do to the shape of our ring? Does that differential heating cause us to do a potato chip shape or something like that? So there are all kinds of things like that that we'll be testing there in orbit.
That's
Yeah,
pretty
so that,
incredible.
I mean, that's a really near-term project, and we're pushing ahead on that. That's our next step. And then following that, we'll have proven that technology for the fabrication of the truss and worked out all those dynamics. So then we can start moving into building a full-scale star, which would build the truss for the Voyager station. And our hope would be, our plan, our roadmap is to launch that and have that truss for Voyager starting construction in 2025, possibly beginning of 2026.
Wow.
So from that point on, it's a matter of then building out the rest of Voyager station. And you know, there's really no with SpaceX and Starship and the launch cadence that they're hoping to have by 2025, launch capability shouldn't be an issue anymore. So then it's just how quickly can we fabricate the components on the ground, get them assembled and, you know, on orbit, and then spin up Voyager and test it. So our roadmap is showing operation beginning on Voyager in 2027. I think if anybody has spent any time in space, you know, the business of space, they know that you set benchmarks and timetables and they get extended out. But
Yeah.
But that's our plan. That's our target.
That's
Well,
incredibly close.
It's physics, and as Tim said earlier, it's the funding profile.
Yeah.
Right.
Wow, that's incredible. So what's going to happen to the gravity ring? Is that going to just be some sort of? It seems like it's just to prove and you know, experiment on all these different elements that are a must to understand. You know, the differentials of temperatures and, you know, figuring out how to, you know, manipulate the, you know, the motion of the entire station. If it all works and the gravity ring is in shape, like, you know, is it going to be deconstructed? Is it going to be turned into its own platform eventually? Just
Well,
random thoughts.
you know, it's funny you ask that because actually yesterday we were on a call with someone from NASA
Mhm.
talking about that same question. And
Yeah.
ideally, what would happen is what we want to demonstrate and prove for us, we're actually going to be able to build the whole gravity ring in less than a day. We'll be able to do our testing over maybe a period of a week or two.
Wow.
But we really want other partners to come in, other space agencies, educational research organizations, you know, anybody who's interested in studying rotation or low gravity environments to come in and partner with us, because then we can modify the design of gravity ring to accommodate maybe a habitat. NASA could potentially have a habitat attached to the gravity ring, rotate it up, and see how astronauts, you know, a crew of 4 fares for a year at a time or 6 months.
Yeah.
Right. So there's lots of different applications. What we need it for, we're looking at just bare bones proof of concept, cheapest thing possible. But ideally, we have some partners that give us some other options.
And the
And
gravity ring will also. Sorry, go ahead, Tom.
I'm designing parts of the station for that expandability. The way we design some of the structural members, you put attachment points on it. So you're not sure what it would be, but if somebody later on wants to attach something to this, they have a place where they can put in a couple of bolts, and whatever it is they want to put on is now attached to the station and can get some electric power and so on. And of course, you have to maintain balance, and we would provide ways to do that. But we're building it up front so that these expanded capabilities that we can't anticipate right now aren't ruled out.
Yeah.
Voyager station ideally is operational in 2027, and that will be the ideal test bed for long-term low gravity research. But you know, with the Artemis program, NASA's hoping to get back to the moon a lot sooner than that. Elon Musk and SpaceX. Elon Musk just announced that, you know, he's thinking of sending the first ship to Mars in the next year or two. There's technologies and equipment, you know, environmental control systems, biological systems that we can test really quickly and in low Earth orbit, where it's easily accessible on gravity ring. So
Yeah.
Actually, it's, you know, it's great that you have the show. Hopefully some of your listeners are connected to some of these research organizations, because we'd
Maybe.
love to have interested parties contact us, and we're reaching out. You know, we've already got a database of people that are potential users of the gravity ring. But you know, it's a shame to build this whole thing, fly it for a couple weeks, and then just, send
Right.
it back crashing into the atmosphere to burn up.
I'm sure it's going to be used. Is it going to have now? Voyager's going to have 1/6 gravity. Is that right? I believe 1/6
Yeah,
gravity.
that's what we're designing it for currently.
So the gravity ring, is
And
it going to be the same?
we're looking at maybe being able to spin it up to Mars G. We may over design some of the structure so that maybe in the future we could spin it up to Mars G. It may be that we have to build a separate station to do Mars G.
Okay. Do you think the gravity ring will be able to? You could test that to see if it's possible.
I'm not sure we want to test spinning up to Mars G if we
Yeah.
designed a lunar G.
True.
The failure mode there is not one I would want to participate in.
Right. Well, that actually kind of rings to one of my questions that I want to ask. It's, is there any sort of like next generation materials that you guys are working on? And Tim, I know you have a construction company. Do you have some sort of a patent you guys are working on that's going to have, the ability to withstand the force of spinning it up to Mars G?
Well, that's one of I think the interesting things of our approach is we're trying to achieve our plans with readily available, proven technologies.
Yeah.
Because getting hardware flight tested and developing new alloys, that takes time, takes more money, and there's really nothing from a technological standpoint that's prohibiting us from creating artificial gravity habitats. The only really impediment up to date has been political, right? Because most of the money spent in space has been funded by government agencies.
Yep.
Now we're
Or the
starting to see
military.
SpaceX, Blue Origin, ULA, Boeing. They're starting to venture out and do some of their own projects, but still the primary driver for space exploration has been government agencies, and there just hasn't been the political will. So what we're trying to do, we're bootstrapping this thing together, right? And we're taking an approach of, okay, what technologies and materials are available that we can use. Like for gravity ring, we're using off-the-shelf rocket engines, right? Now each one is still custom made, but it's a proven engine. That they have flight time. That we're not inventing something new. So for materials for gravity ring, we're looking at aluminum or steel. For Voyager station, we're looking at for the primary trusses, we're looking at aluminum for that as well.
Okay.
And the flight proven aluminum alloys, they're readily accessible, they're relatively inexpensive, and there's fabricators that know how to work with them as well. So that's the other piece to it.
The other thing that has made this the right time to do this is the decrease in launch costs. There have been political impediments for sure, but there was a financial impediment 10 or 20 years ago, and that financial impediment is slowly eroding away as companies like SpaceX and Blue Origin and ULA are shooting at much lower launch costs.
Definitely.
Well, and really that's our doorway into this, right? It wasn't possible prior to the last decade for private companies to even start to do these sorts of things because launch costs were so high. But now launch costs, like Tom said, are falling. So that makes it possible for companies like ours and others to start to develop space and start to think beyond what just the NASA offerings are on the International Space Station. We can start looking at doing much bigger projects.
Are you working with any government agencies yourselves? Do you guys have, anybody that's talking to you about maybe, being a part of that whole crew, basically where the money's at, as far as what space is right now?
Well, yeah, Tom and I both know several NASA employees. Over the last couple of years, we've had numerous meetings, been to Kennedy Space Center. I've talked to the people who built the International Space Station who are currently maintaining it. We've sat down and discussed what our plans are. The challenge with NASA, and like I said, we just had a conversation yesterday with a NASA employee about the same topic, and the challenge is this tug of war that NASA administration has with whoever's in the White House, right? So we've just had an administration change, and each new president and administration wants to have their big Kennedy moment for NASA. They want to have their kind of historic moment. For President Trump, he called on NASA, let's get back to the moon. And so the Artemis program got a lot of focus and emphasis, and that started to get pushed along. That it's still too soon to see what the Biden administration's focus is going to be, but we're actually working on a document where we're outlining our plans for the Biden transition team, and we do have some high-level connections with the Biden administration. We have some friends there, so our hope is that and from our standpoint, the development of the moon is a good thing for us. We don't necessarily want the Artemis program to go away. But there was a NASA program, the Next Step program, where they had a series of milestones that created, for example, the commercial resupply mission, that partnership with SpaceX, also the Crew commercial mission. There's there's habitats that are being docked right now at the International Space Station. Those are all partly funded by this Next Step program. Well, there was an Appendix K as part of that program that this last budgetary cycle was defunded, and that was supposed to fund a free flyer space station, basically a habitat that NASA could lease. Yep, there you go, right there. Yeah, the Next Step K. Yeah, that's the one. So this was supposed to fund
an important part of that.
Yeah. So that was going to provide funding in part, not full, but in part to commercial partners to develop a free-flying space station completely separate from the International Space Station, with the idea that NASA could then lease space from those commercial partners. So that didn't get funding this last budgetary cycle. So one of the things we're asking the Biden administration is to continue that pattern and fund those programs where the government agencies can help to kickstart some of these commercial ventures, because for us, the hard part isn't really getting the second $100 million. It's getting that first $100 million, right? There's very few investors that want to be the first ones out the gate to say, okay, I'm gonna fund this. And so if there's government backing or some money that can be pushed into these programs, where now private companies can have a little seed money to then go out and get the rest of the funding to finish the deal, that spurs on these programs. Now we have also another problem of we're a fairly new company. We don't have any hardware that's been sent into orbit yet, right? And so SpaceX, before they first launched their first Falcon into orbit, they were looked at as like a bit of a joke, right? NASA and everybody in the space community just shrugged them away and said, it's just Elon Musk. He's bored. He's got all that PayPal money, nothing to do. They got something on orbit. They tested it out, it was a success, and then boom, they got a NASA contract to start for the cargo resupply. So we know we have an uphill battle as well. That's what we're pushing to do Gravity Ring and P-Star. We want to show that, and the D-Star demonstration that we're currently building. We want to show that we are a legitimate company. We're building hardware. It's not just Tom and myself drawing pretty pictures and playing with equations. Yeah. And so there's all these little pieces that come along, and then that hopefully all come together and create something wonderful.
Yeah. Now, and you're a planning commissioner.
I am. Yes.
How do you think the whole zoning thing's going to be going on? Is there going to be is that going to be heavily regulated as it is on the ground? How do you see it happening?
We're in the wild west of space, honestly. I mean, if you think about the spreading of people from the East Coast west in the 1800s, there were some general kind of federal guidelines and rules, and but for the most part, people got out there and they just did what they wanted, right? There wasn't any law enforcement.
This is my backyard now.
Yeah, I mean, there was a sheriff in town possibly, but if you didn't like him, you just killed him, right? I mean, that's kind of where we're at with space right now. There's a lot of people,
not that extreme, but
well, but it could be. There's countries. Well, so we have, for example, China. They're just kind of a rogue state in space
yesterday, right?
What's that? I'm sorry.
They just went back, I think yesterday, wasn't it?
Yeah.
Or 2 days ago.
Yeah. I mean, they're not playing by any rules, right? They're just doing what they want, and they're accelerating to try to develop the moon and Mars before we do. You have Russia, which recently announced that they're going to build their own space station and leave International Space Station. So there's really no
China also. is doing the same.
Yeah, China announced that a few years ago. They've been pushing towards that.
Right.
But so the challenging part with that is what regulatory body is going to step in and organize space. Now the
Yeah.
nice thing about space is it's a lot bigger than Earth, right? There's an infinite
Yeah.
amount of real estate. You just have to develop it. So,
Right.
but what I probably see happening is, individual countries are going to start to create regulations for equipment and operations that are based in their home countries. Ideally, I think the UN could pull people together. We just had the Artemis Accords that was, headed up by NASA, and there was buy-in from a few countries on how we're going to develop the moon, but China wasn't a part of that. Russia wasn't a part of that. So, ideally, I think we have some of that big picture just coordination. But I think what's probably going to end up happening, at least in the near term, is we're going to have some sort of turf wars, honestly.
I think so too.
Who gets there first, right?
Yeah.
But if you look at like the individual countries' regulations, so like in designing Voyager Station, there's no building codes, right? As a licensed architect, I spend a lot of time poring over codes from cities and counties and states and trying to make sure that we're in compliance for all the life safety issues. There's none of that for Voyager. NASA has an extensive library of recommendations and best practices, but they're not enforced. Now, if you want to have NASA lease it and use the hardware, then you would need to comply with their guidelines. But it's really we're making it up as we go along. For example, like in Voyager Station, it's a low gravity environment. NASA doesn't have any guidelines on how you should develop low gravity environments. They haven't done any work there. So in designing, for example, the habitats, we went back and looked at. That's what I was saying. I think in my bio there it says, below base zero thinking. We had to go back and look at, so how does the human body function? What are the physics? What are the Coriolis forces? What's the direction of rotation? And then how do you design a space to make people as comfortable as possible? So ladder orientation, stairs. We're gonna have multiple floors in these habitats. You don't have to design the stairs like you would on Earth, where you have, a 12-inch tread and a 7-inch riser, because you weigh 1/6 of what you do on Earth, right? So you can take much bigger steps. Simple things like getting out of bed, right? When you sit up in the morning, you don't want to feel nauseous because you're sitting up, and you were having some Coriolis, effects in your head and your inner ear is going nuts, right? So there's all those little things we had to go back, and it wasn't just a simple layout of the space, like we took an apartment or a hotel from Earth and dropped it into space, because you have to go back and start thinking through all the building codes, like why do we have, like, what are the life safety issues? How do you evacuate somebody from a module? John Blinkow, our CEO, and Tom Spilker, they like to play this game where they get together for lunch and they just start poking holes in the space station, and how do you deal with that, right?
Yeah.
Start thinking through the different failure modes. How big of a threat are they, and how do we mitigate for them?
Well, that's good. We need people like that, because all the contingencies need to be taken care of.
Yeah, so this is a long-winded way to answer the question of, I think at some point there's going to be building codes for space. There's going to be zoning ordinances for space. But all of those codes and ordinances were developed over time, and we're just in the early phases of all that.
Okay.
But there will also be things that maybe aren't quite obvious. For instance, here on Earth, in the United States and in various places in the United States, we have building codes. The number of people who can't negotiate a normal curb at an intersection is relatively small, but we have building codes to make sure that those intersections and the curbs at those intersections are built so that people who are mobility challenged can negotiate those curbs. Wheelchairs and so on have an easy time going up. There will be similar kind of things on a space station that maybe they're not completely oriented around survivability or something like that, but something to do with comfort. For instance, we're designing the station so that we don't have a large crew whose responsibility is to clean barf off of the floors and walls.
Right.
We're having a slow rotation rate and a large radius, and our radius and rotation rate is such that only a very tiny percent of the human population would have any problem with the rotation.
I just saw it spinning over there. I figured I'd bring it up and kind of show a visual representation of. Now, this is this Voyager here.
That's
this one
Voyager Station, yeah.
that we're showing.
And Tom actually touched on another whole interesting topic. You know, in low gravity environments, people who have physical disabilities are going to have a lot more freedom potentially than they do on Earth, right? If you have, you know, if you have difficulty with mobility, or you're constrained, let's say, to a wheelchair, you might be able to walk around in a low gravity environment, right? Or at least be able to pull yourself in and out of different situations that you wouldn't be able to on Earth. So there, you know, when people look at, you know, living in space, I know John and Jeff talked about this with you on your last interview about kind of this escapism, like building habitats in space to escape the problems on Earth. But really, I think for a lot of the population, moving to space is going to be liberating and freeing. We were talking also just internally about, you know, potentially having hospice care. You know, people who are maybe, you know, 80 plus. You'd have to survive the launch, so there'd be certain you know, requirements at that point. But you know, spending the end of your life in space, where you're having a hard time getting up and down the stairs here on Earth, but space, not a problem, right? You get a lot of your freedom and mobility back.
Yeah.
So I think there's a lot of potential, you know, in that realm as well.
So I asked
There's
them.
Also potential.
Go ahead, Tom.
There's also potential in terms of medical sciences and medical procedures. There may be certain medical procedures that are really difficult to do in 1G. Tissues and so on are wanting to head toward the floor, and it's maybe really difficult to get a particular procedure done in 1G, but you take them up to a 6G or less than that, and the procedure is much easier to do. Now, just like the frail person who has to survive the trip up, the person would have to survive the trip up to space. But if it's the procedure itself and not their condition that would really like to see low gravity, then there may be an opportunity for hospitals with operating rooms in space that allow procedures that you just can't do on Earth.
That's a really interesting point of view that I never actually thought about, because, you know, the blood wants to go down to the floor. You know, suddenly you can, you know, move everything around a lot easier, and wow, that's cool. It's a cool thought.
Well, and also, you know, the newer launch platforms like SpaceX Super Heavy are going to have a lot lower Gs to orbit than some of the older craft. So not only lowering costs, but lowering the barrier to space from a physical standpoint is on the horizon as well, to where, I mean, right now, if you had a terminal illness or you needed an operation, you're not going to be going on a Soyuz craft and launching into space.
No.
It's not very
the Blue Origin plane, though, doesn't it fly and then, you know, fly up into the atmosphere, or, you know, outside the atmosphere? You know, you think about that.
You're thinking of Virgin Galactic's?
Oh, I'm sorry. Yeah, that's what I'm thinking of. Yes.
Yeah. So that's even less G forces what they've got.
Right.
I think, you know, all these things are going to be feeding in on each other. So as we build it's like the Sandlot, that movie, right? If you build it, they will come. As we build the infrastructure,
Field of Dreams.
Or sorry, Field of Dreams. Yeah, wrong baseball movie. But as you you know, as you build the infrastructure, then all these other applications are going to start to materialize and develop themselves.
Yeah. Wow, it's really cool. A lot of I mean, advances in everything, you know. This is truly the future, you know. Even this conversation, I've already been my mind's, I feel it expanding, and really, I mean, it feels like sci-fi, but it's really not anymore, you know. What do you guys Star Wars or Star Trek?
Well, that's a hard.
You have to pick one. Come on, you got to pick one.
I've probably
why do
watched
I have
more.
to pick one?
Because that's the name of this game I just made up.
So
Are you saying both, Tom? Both?
I've rewatched
I
the
watched
Star
both.
Trek series more than I have the Star Wars movies. So it'd
Okay.
probably be Star Trek for me.
All right, me too. Star Trek.
But I'm really into Mandalorian right now. It's a good show.
I haven't seen it, but I'm definitely going to start watching it soon. I'm excited about it. Yeah, it's that's where it all came from, right? I mean, we, all the boop, boop, boop. This was so far-fetched, tapping on your chest and being able to talk to someone in space, but we can literally do that now.
Well, and I think
Adam,
one of the
you've
things
seen the T-shirt that it says at the top, #1 Star Wars fan, and then it shows a picture of the USS Enterprise.
I haven't seen that.
I'm a big fan of Battlestar Galactica as well, just not the whole android.
Good show.
Not the androids killing the human race, but it's
they needed to create drama.
Yeah, but they have big cities in space. They have these big ships. They're self-supporting. It's another great paradigm. One of the things John Blinkow says a lot about kind of the bigger vision of what we're doing with Orbital Assembly and our other kind of organization, the Gateway Foundation, is creating this whole idea of starship culture, which is inspired from these different programs where going to space and living in space, working in space isn't for the elites, for the people who've trained their whole life to do it.
Yeah.
If you want, Adam, if you want to go and get a job on the space station, working in the bar or playing your guitar or doing a podcast,
YouTube. I could stream from space.
Yeah, I mean, we want you to have that option, right?
Yeah.
If you want to live in space, you can do it. So I think that's the direction we're heading. And I mean, for the first time in my lifetime, it's really on the doorstep. It's years away, not decades away.
Yeah. Well, I was going to ask you guys earlier because I asked the other gentleman that joined me, what do you say to the people that are very interested that think they have no chance, that like you just said it, it's not about the elites, this is going to be normal, space mining, heating and air conditioning, all these different facets of trade is going to be part of this whole space culture. What did you call it? Starship culture. I like that, but how do they get into it? What would you tell somebody that has no idea where to start?
The main thing I would say to them is to there's this attitude of, oh, well, I can't do that. Put that aside.
Yeah.
Sometimes there's a reason somebody can't do something, but if it's only an attitude of, oh, well, that's only for elites, put that aside. Don't be your own impediment.
Yep, I like that.
Yeah, I think also I like the whole gold rush settling the West paradigm, because I feel like what we're doing is we're building the railroad. Well, SpaceX is building the railroad. We're building the hotels, right? We're building we're building the other infrastructure. But we're working on building out this infrastructure. But if you look at like the gold rush in the early days of California, the people who really became wealthy weren't the people who were mining for gold. It was the people who were doing the laundry, the cooks.
Yep.
Somebody just outside my window now is starting to do some construction.
I can barely hear that, though. It's fine.
Okay. Yeah. So, it's the people who are doing all of the support for the people who are providing the main mission.
It's a good point.
And so,
the bars, the hotels.
Right. Yeah. I mean,
the
and people say
things in life that we need.
Right. So we were actually our story about the space station was featured on the Daily Show last year, and there was a joke about, oh man, who wants to go live in space and work in a hotel, cleaning up the suites, but there's gonna be people who want to do that, right? I mean, I think that would be awesome if I was in my 20s and I was looking for a first job. Do I want to go work at a hotel down the street here, or do I want to go to space and work on a hotel?
Yeah.
So I think there's going to be lots of opportunities there.
It's pretty amazing. So, I mean, even if you're just a cook, even think about, they're going to need cooks in a hotel, or even a bartender, simple, but, or I don't know how drinks in a low G probably be a lot of fun actually, but,
and that's one of the things. I'm
Oh,
sorry.
Tim, you're fine. Don't worry about the. I can barely hear. I hear what you're talking about. Their construction out there, but don't worry about
Yeah, I mean, it's the worst time. It sounds like they're trying to cut through my office wall. But
it. It's just bad for you. Don't worry, Tim.
yeah, it's probably the NASA administration. You know, they're upsetting me for bad mouthing them. But you
No,
know,
when did you badmouth them? No, you're good.
yeah. So I guess I was thinking it. That's the problem.
Well, now you admitted it.
So they defunded the
Oh,
appendix
right.
K.
That's right. The next step, K, right?
Yeah. So what I was gonna say though was, you know, when we're looking at jobs in space in the early days, it's gonna be people who have engineering degrees, people who are machinists, people who have
Yeah.
some construction background, people in aerospace, right? In the next few years, those are the people we're gonna be hiring. SpaceX is hiring them like crazy. Blue Origin is hiring engineers as fast as they can.
Yeah.
You know, that's where the immediate demand is. But in 10 years or so, when we start to have all this infrastructure and these other things operational, you know, that's what I'm talking about when I'm saying, like, you know, if you want to go to space, there's gonna be an opportunity for you to do that.
Yeah. That's great.
Well,
It's coming.
Yeah, it'll take a while for people to design the equivalent of the bulldozers. I mean, when we started on the interstate highway system and the roads about a century ago here in the US, they needed a lot of big equipment, bulldozers, cranes, steam shovels, various kinds of earth movers, and so on like that. People had to
Yeah.
design those. And of course, those were engineers. And once they got designed, well, the companies that built those could just continue building them. Then what you need is the backhoe operators and the bulldozer drivers and so on. Once we get the equipment designed and start building it, then we'll need the people that operate it, and those won't be engineers and scientists. And especially for things like if we're using Voyager Station for a hotel, like we hope to, we're going to need people who clean the rooms.
Yeah.
As we mentioned, all of the kind of people that would operate in a regular hotel, we're going to need those people just in orbit instead of on the ground.
Well, there's also industries and businesses that we haven't even imagined yet they're going to be starting, right? So one of the things that we're building on Voyager Station, we have 2 recreation and gymnasium modules. They're
Okay.
20 meters long, 12 meters in diameter. And, you know, right now we're thinking, hey, we can do like low gravity basketball. We'll have trampolines. You'll be able to, Tom came up with this game where if you can do it just right, you can kind of run sideways around the perimeter of the module. But
Sounds like fun.
It's actually vertically. You can
over
run
the
across
top.
the floor.
Yeah.
You
That's
can
cool.
run across the floor, up one of the walls, across the ceiling, down the other wall, and back to the floor. If you can run 6.2 miles per hour, you can do that.
Wow, that's cool. I actually have this game that I kind of am working on called All Ball. And it goes back to the other show that I was on. And we wanted to create some sort of a new kind of a game that, you know, there's a bunch of different sports kind of combined into one. And all I can think of when we're talking about this is this, like, can you imagine the games that are going to be played in this
Right.
kind of an
yes.
environment?
That's exactly what I was talking about. You know, there's going to be businesses and entrepreneurs who are going to start creating industries around these kind of facilities, right?
Yes.
Sports equipment for low gravity. There could be low gravity sports leagues, right?
There's gonna be. There's absolutely gonna be.
Right. Yeah, and then also, you know, we're building infrastructure. We're building habitation modules, right?
Yeah.
There's going to be people who are buying and selling, and, you know, there's going to be realtors in space. There's going to be people operating businesses in space. There's pretty much everything that you can think about on Earth. Maybe not farmers right away. We don't have any farms on our stations, but you know, these things are going to start moving into space.
But there will be, right? We're gonna need food.
Yeah.
It's not like we're gonna be able to just keep shipping up food from, you know, Earth.
Yeah.
They've grown wheat on the International Space Station. From wheat, we can make a lot of different things.
Well, definitely with the Gateway, which is the much bigger long-term project, we want that to be completely self-sufficient. So that would have its own food production on there.
Right, right. What is the time frame on the Gateway?
I don't know. Have we put a date to that one, Tom? I don't. I don't know if we have a date on that one.
No, we haven't really started to do serious engineering on that. There's
This,
yeah.
that's
Now,
just,
one of the
That's Voyager right
unfortunate
there.
things.
I
This
had,
is
there it
Voyager, and
is.
unfortunately, this video kind of jumps back and forth between the Gateway and Voyager, and people get confused by that.
Yeah, this is
But
the Gateway here, though,
Right.
right?
yes,
Much
yes,
bigger.
and Voyager would be a little bit larger than the central hub of Gateway.
Oh, okay.
Yeah, I think if you scroll down, there's a size comparison. If it's not on this site, no, maybe
Okay,
not.
maybe
No,
not.
we didn't put it on this site.
May have just passed it. I thought I saw Gateway
Yeah, if you go
plus
up,
the international.
right. Yeah, so
Oh,
Voyager,
here's the International Space Station. Okay.
yeah, and Voyager station is about twice. So
Of the
the
ISS
International
here.
Space Station is about 100 meters. Voyager's about 200. So it's about twice the diameter as ISS is long.
Oh,
Yeah.
okay. Wow. So it'd be inside this ring almost.
Right. Yeah.
Wow. So this is massive.
Yeah. So the idea with Voyager is it's a stepping stone to creating, large amount of real estate, low gravity environment. And then we envision a whole cluster, a fleet, if you will, of these Voyager class stations. We're going to build the first one, and we're modularizing it all. So
Yeah.
all the 24 modules around the perimeter, we build number 24, and we just go on to number 25 and start building the next station. So the idea would be, we'll have the first station will go up, and then we're going to keep iterating and just keep building out stations. We'll have stations orbiting Earth, stations orbiting the Moon, Mars, possibly even going, transit between Moon and Mars.
So would you be able to move one from Earth's orbit to lunar orbit, or transport it over to Mars orbit eventually? I mean, how many stations is going to be too many? Like clog up the skies, or would you even see them with the naked eye?
Yeah. So like I said earlier, space is really big.
Right.
You just move it to a different orbit. I don't think we're ever going to run out of space. But transiting between planets, Tom, do you want to tackle that one?
Yeah, that becomes a matter of how much propellant you can put on one of these things. Changing orbit at Earth takes a certain amount of propellant, and once we put up one of these stations, you wouldn't want to change the orbit much, just because it takes a lot of propellant to do that. Changing the altitude a little bit is not too bad, but changing the orbit inclination, any other thing that would require precessing the orbit, that takes a lot of propellant. The amount of propellant it takes to go out of Earth orbit to another planet is another order of magnitude larger. It takes a lot of propellant. Plus, if you start pushing on this station, you have to be very careful about how hard you push, especially if you're pushing perpendicular to the plane of the station, pushing along the rotation axis. You can put some big stresses on spokes and things like that. So you would have to do this slowly, but unfortunately, that means you spend a fair amount of time in the Van Allen radiation belts. So there's some problems to be worked out there. It may be that if you're wanting to send one to another planet, you start from a high Earth orbit, say geosynchronous orbit, or even orbit around the Moon, where you're out of most of Earth's gravity well, and the amount of speed change that it takes to get from there to an interplanetary trajectory is not quite so large. So it might be that, yes, we could do that, but you probably wouldn't do it from low Earth orbit.
All right, so they would be custom built per planet, essentially. You'd build a Mars station. Okay.
Well, and that version might actually be a version of Voyager station that's designed for Mars gravity. So you could board that when it's in, let's say, coming in for this loop around the Earth, and then you're in a Mars gravity environment for that journey back to Mars. You're acclimating, or I mean, now we're getting into kind of the theoretical stuff. Definitely not on our roadmap, but once you start playing around with this, there's really a lot of different possibilities and options. Once you start thinking bigger than, tacking on another small module to the International Space Station, right?
It's awesome though.
And if you come in, and again, thinking theoretically, the Voyager station is essentially a ring. It's broken up into modules, of course, but it's essentially a ring. And the rotation rate and the diameter of that ring tells what kind of artificial gravity acceleration you have. Well, there's nothing that says you can only have one ring. You could put another smaller ring inside that. And if you've been in 0G for 6 to 9 months for the trip to Mars, it may be that going straight to Mars G is not the thing that you want to do. You want to start with maybe lunar G at that smaller interior ring. And then as you get accustomed to that, transition to Mars G on the outer ring. And that would ease that transition from months at 0G to Mars G, make it a whole lot easier than the astronauts coming back from the ISS have seen.
Yeah.
Yeah, and you actually were showing there on John's video there, I think he was kind of going through the history of rotating stations.
Mm-hmm.
There was one other one he's shown. I mean, rotating stations aren't new, right? Werner von Braun, he did a whole special with Disney on it back in the early days of the Apollo missions. And the cycler that we're talking about, yeah, and the cycler craft that we're talking about going between Earth and Mars, there's people that we've talked to that they put a lot of time into that. That's kind of their specialty. Tom and I aren't experts in that, but there's a lot of people that are thinking through these different problems and creative ways to solve them. I've seen some interesting renders on Twitter as well of people putting tethers on SpaceX starships, with a counterweight and spinning those up and sending that to Mars. That introduces a whole new set of problems, which Tom and I have our thoughts on tethered AG systems as well.
Explain what a tethered AG system would be.
So that would be where you have a habitation module on one side, and then you have a mass that's attached to it, and then you reel out a tether, and so now the mass is out here, right? A counterweight, and then you have got thrusters on it, and you start to spin the whole system around, and so you get rotation with a counterweight. Now the argument in favor of that, and there's people that are really committed to this and are definitely more experts on it probably than I am. But the idea there is that you can use existing hardware, you can use existing habitats, and it's a cheap, easy way to induce some rotation and create some artificial gravity.
Okay.
Now the challenge with that though is what happens when you want to stop or change that rotational rate, because you don't have a fixed point that you have a cable between the mass, your habitation and the counterweight. So
but they would both be spinning around, or just the one would be spinning? So the middle would be turning with it. Just trying to.
They spin around.
It just feels like
they spin around their
dizzy.
common center of. They spin around their common center of gravity.
Okay.
So wherever that center of mass is, both of them will spin around that.
Okay. All right. The center point.
Yeah.
Interesting.
So we actually have in the early days. We didn't just completely rule out tethers. We were looking at them. We've talked to some people who are experts in trying to develop this tether technology. We feel that rigid bodies are really a much more controllable system.
Right.
So even if we were to do the ring is definitely from a mass and balance standpoint the easiest thing to rotate. But if we were to go to like a rigid body, we could build a truss, and put like a habitat on one side and a counterweight on the other side. That would be our preference as opposed to a tether.
So basically, a solid tether,
Essentially, yeah.
Right. Okay. Just altering it. So before we don't have too much time left, but I would love to ask you, Tom, a few questions. This is, I don't know if you recognize this photo. It's not actually a photo. It's it's fake. Now I know it's fake, but you did work with on the Cassini spacecraft, correct?
Yes, and my wife is the project scientist for Cassini.
Oh, cool. Awesome. That's really cool. I want to know how accurate. I know it's fake, but how accurate is it? Could it be? Is this could have been what it looked like as it took its final dive into Saturn? I had to ask.
This is pretty close, let me tell you.
It's pretty close, huh?
Yes.
That's awesome.
Yeah.
Because I saw this photo. Go ahead.
They don't have the antenna pointed in the direction that the spacecraft is moving. The spacecraft in this, we'll call it a photo, is moving from left to right. as it's coming down towards Saturn's atmosphere.
Okay.
And the antenna is pointing at Earth to get those last few bits of information about.
Keep sending
You
it out.
start getting into Saturn's atmosphere, and you're in a place you have never ever been before. So what is this atmosphere trying to tell us in what it's doing to the spacecraft? And that antenna is sending those last few bits back to Earth.
That's awesome.
Yeah, one of the cool things about being friends with Tom and Linda Spilker is you get these
Yeah.
cool commemorative Cassini pins. I'm not sure if you can see that.
Grand finale. Oh, that's awesome. That actually kind of looks like what this image looks like.
Yeah.
That is very cool. Wow.
Whoever designed that did a great job. The place in the rings where there's a gap, the Cassini division, is actually a hole in the pin. So when you put it on your shirt, the color of your shirt shows through, which means you can wear it with anything.
Yeah.
Oh, that's awesome. Wait. Let me give you
that. You got to see where the color bleeds through there.
I can see it. That is very cool. Man, I'm a little jealous. I'll be honest. I love it. That's great.
Like I said, you got to have friends in the right places, right?
Why do you think I have you on my show? You know, I'm building a rapport here.
Well, you're at the beginning. Ticket to space. Come back to us in a few years. We'll see what we can do.
Done.
Yeah.
You heard it here, folks. I'm gonna be in space eventually. I've been saying this for all year. I'm like, I'm gonna be in space one day. Now I have confirmation. Just got to wait a few years. That's okay. I can wait. I don't mind. I don't mind waiting. And
Adam,
then
here's a
also
little something for you.
Ooh,
here's a little
ahead,
something for you to think about for future shows with who knows who. But
sure.
If we go down the path of artificial gravity, and we're doing lunar gravity and Mars gravity, and we get populations living on Mars and populations on the moon, if those people are born and grow up under those gravity situations and never experience 1G, they can never come to Earth. Their muscular and their skeletal development will be driven by the G that they're seeing. And if they come to Earth, they break all their bones immediately. So it may be that after generations of that, we develop a bifurcation in the human species so that there's a terrestrial-based half of the human species and a space-based. And it's fairly easy for people from Earth to go into space as long as you get some artificial gravity, but pretty much impossible for the other half to come down to Earth. So we may wind up with a bifurcated population.
The Belters. I don't know if you've seen The Expanse.
Part of it, yes.
Very cool show. And it basically goes over that. Like there's the Belters. They live out on the, the asteroid belt mining, different for water, for precious resources. And they have grown into very tall beings because there's no gravity holding them down. They're in one of the episodes, it shows one of the Belters go to Earth, and he's being tortured actually by just simply being propped up, standing up, and that alone, because he's just being pulled down and it's destroying his body, and it's kind of brutal to watch. But
there may be a way. Well, I'm sure there is a way to combat that. If there was a goal that people living off world could develop and still acclimate to be able to return to Earth regularly, you could develop therapies that people could do exercises and enhanced gravity environments for certain periods of time. I think there's probably a way around that, but I think what's going to end up happening, kind of what Tom's saying, is you're born on Mars and you have no desire to go back to Earth. So why am I going to put myself through all these exercise regimens and therapies every multiple times a week to go to a place that I have no intention of going, right?
Well, I mean, the ability to just breathe in and breathe out without a spacesuit would probably be rather lucrative or exciting. I mean, of course, this is me being here thinking that I take it for
Elon
granted.
Musk has his way, he's going to terraform Mars, and then
how long do you think that's going to be, though? That Mars could be fully terraformed,
right?
I know there's talk of an artificial magnetosphere, having a kind of a sort of shield, at the Mars Lagrange point, that kind of creates this artificial magnetosphere, but I don't know if that's how far down that is and whether that would even work. And would it create, an oxygen environment that we could even breathe on Mars eventually? These are
Well, you
these are
might
some
be
serious
able to
questions.
generate an oxygen environment. There's plenty of oxygen at Mars. It's just a lot of it is bound up with carbon and with silicon in the rocks and so on. You could liberate that
Huh.
oxygen, but even if you had this magnetosphere,
Yeah.
Mars is small enough that its gravity is weak enough that molecules significantly lighter than carbon dioxide escape fairly quickly, and
Right.
oxygen is a lot lighter than carbon dioxide.
That's the problem.
Yeah.
So how do we keep the oxygen in? How do we create an atmosphere on Mars? I know it's a whole
Well,
nother conversation,
yeah. Have
but
you seen the
Well,
movie Spaceballs?
yeah,
They
I have.
so you put
Where
a
they
big
open it up and
exactly.
suck all the oxygen out. Wait, is that a possibility though? Is there someone
Wow.
out there sitting
No,
on
I
their
don't think
drawing
so.
board trying to design like
Besides
a
Mel Blanc.
Mars shield?
Yeah.
Wow. That's crazy to think about though. My goodness. And
well, but
also, go ahead, Tom.
with the opportunity that's coming up with the decrease in launch costs and getting some big pieces of equipment and factories and so on in space, it's not going to be all that long that people are really going to have to be thinking about these things.
Yep.
Yeah.
I
We're
mean, we're
moving
not
there.
talking 1,000 years down the line. We're talking maybe 50 or 100 years down the line. So people who are toddling around right now may be the people who need to make the decisions about all of these.
That's amazing. We're really in the middle of becoming a tier 2 society, right? I think that's what it's called. We're tier 1 now. Moving to a tier 2 is that when we colonize the solar system, I believe. I think I might be getting that wrong, but that's the next step, is colonizing the solar system. We're there.
Yeah.
We're watching it happen right now, and companies like yours are, like you said, you're not building the railroad, but you're building the hotels, and that was basically hand in hand with the Wild West, taking over and bringing civilization. I know that might make people angry about what that means, but it doesn't matter. It's already happened, so space is truly there, and we are actually watching it happen right now. It's pretty incredible.
And we're
Yeah. I mean,
hoping that in
go ahead.
developing the hotels and the other things that these stations will be useful for, notably, they're not just zero G hotels, they're artificial gravity hotels and artificial
Right.
gravity laboratories. And seeing what zero G does to people, it was obvious that our ability to travel the solar system was limited. With
Right.
the introduction of rotational artificial gravity, suddenly we'll remove those limits. And I look
Hopefully.
at it kind of like in one of the Star Trek movies, they were really playing up the fellow who did the very first warp drive and first cut
Yeah.
in the warp drive, and what a change that made to humanity. Well, we're looking at the future being in rotation by introducing this rotation into space flight and making it possible to spend a long time in space without all of these debilitating problems you get from zero G. It will be kind of opening up the solar system the way Star Trek saw warp drive as opening up the galaxy.
Now, is that the next step? Turning these space stations into, I don't want to say interstellar ships, but we'll say long distance ships.
Well,
Like
I
we
think
see all these movies. Go ahead.
yeah, I think what the thing isn't long distance, but long duration. Because
Okay,
we've
good point.
Duration.
seen, yeah, I mean,
Right, right.
humans living for a year in microgravity have a really hard time, right? And so we know there's some prescription of gravity that's going to make living in space long term possible.
Hmm.
There's the other factors. There's radiation and shielding, which is actually a much easier problem to solve. But the low gravity or that gravity prescription is what we're trying to figure out. And so, and we know it's not 1G 24 hours a day, because we lie down. I'm sitting right now. My legs, my heart's not going to pump as hard as it was tonight when I'm going to sleep. My skeleton's not having to support my weight while I'm sleeping. My blood's not being pumped in my head. So there's some percentage of gravity that makes it to where we can function normally and our bodies can function normally. And NASA actually just released some findings about the mitochondrial, in our cells, the mitochondria, and the effects that space is having on those. And so they're trying. NASA's approach right now is trying to treat everything with medication. Formulate a new drug, formulate some new exercise. They're trying to treat all the symptoms.
Yeah.
Where our approach is, well, let's take the easy approach, deal with the root cause.
What causes it?
Right. And
awesome.
So that's what Tom's talking about. This is the fundamental shift to where you can go to space for more than a year and be able to come back to Earth and not be completely wasted. And and there's so many health problems, right? So
yeah.
if we
Scott
want people,
Kelly went through a lot of different things when he got back.
Yes.
Yeah, I mean, if we want people living and working in space, we need to solve this fundamental problem. And so I think that's what Tom's talking about. When we spin up that first artificial gravity station, that's going to mark the step from being visitors to space to being habitants and occupants of space who are living there long term.
Wow. So that gravity ring, which is going to be the test bed for all of this, you said that it could be as early as 2022 when that's being tested.
That's
is that what you said?
That's our target. Yeah, for sure.
Wow.
And the only thing I shouldn't say the only thing. The big hurdle I see right now is financial, and we're actively working on raising the funds for that. Like I said, we've already started talking with some of our other partners for launch capabilities, for the rocket engines. Manufacturing the truss and the P-Star itself is, from my standpoint, it's just another engineering and construction problem that we can get through. So that funding package, and it's really not that expensive compared to some of the other things. It's not like International Space Station where every component was custom built, had to be human rated. The gravity ring is a series of truss segments that we can mass produce. Right. So it's from a fabrication standpoint, it's fairly straightforward.
And the habitats come afterwards, and anyone can, like, it's almost like getting an engine and everything, and everyone just comes and makes their own kind of car, where you guys are providing this, the truss, the ring, and it has specific, adaptation or whatever you can connect to. So say your company creates a specific habitat, tests it on the orbital ring, everything's a go. So you get a contract for, whatever, and moving forward and prove that your concept has worked. I mean, that's what you want, right? You want these different companies to look at the gravity ring and be like, okay, this is what we're going to be working with. Let's make our own version of, the space hotel, the Hilton, the Voyager Hilton or something. I think I saw Hilton on.
Yeah. Well, for Voyager Station, for sure, we have 24 modules. Out of those 24, 22 are available for occupancy by whatever function. 2 of those are dedicated for the air, water, power, and just operations of the station. But yeah, I mean, if somebody wanted to buy a module and operate a Hilton hotel out of it, or SpaceX wanted to buy a module and train crew, or NASA wanted to buy a module to have their crew and run experiments, I mean, yeah, that'd be fantastic.
But your company is making the modules, though.
Well, that's the plan right now. Yeah, but I think if another company wanted to do it, and we provide them the specs and the integrations to the larger station, I don't think we'd be opposed to that.
Because,
as with many construction projects, it's a decision: do we build it in-house or do we contract it out?
Right. Yeah. Now, gravity ring's a little different in that we have a very singular focus on that. We're actually not planning on putting any habitats on that. It's purely a physics and an engineering demonstration.
Right.
But if NASA or JAXA or a university wanted to have either a human habitat or a habitat with a mammal or some other biological on there, then we would accommodate that, and they would pay for their add-on, but we would build a base structure most likely. Yeah.
Awesome. Well, I'm really excited.
If they wanted to pay for the whole thing, let them go for it.
Hey, you guys want to pay for it?
Right.
By all
Well, and
means.
that was one of the options that we're looking at is when we're finished with it, maybe somebody wants to buy the gravity ring and take over operations.
It's a good point. Yeah, why
Yeah.
wouldn't it not be their own like who says Hilton? I mean, I'm just using Hilton as an example, but they buy it and turn it into the full-on Hilton, the space Hilton,
Yeah, I mean,
right?
theoretically, you could put a habitat on it. It'd be a very small Hilton for gravity ring.
Yeah.
But like I was saying earlier, our plan is to do our demonstration and then deorbit it. We don't have
Okay.
a need for it.
Well,
Not
why
not
wouldn't you
only
keep well, hold on. Why wouldn't you keep that material in space and reuse it if it's already
And I'll take
in
this one.
orbit?
Yeah,
Go
go
ahead.
for it. No, yeah,
If you look at the International Space Station, it's 455,000 pounds,
Yeah.
some 200,000 kilograms, in not a whole lot of area. So there's a lot of mass and not a whole lot of area to create atmospheric drag. Now, even though you're up 400 kilometers, there's still a little bit of air up there. And over
Oh, okay.
time, that slowly slows down the station, and they have to do what they call reboost every now and then. Well, the gravity ring has a lot more area and a lot less mass. The ratio is very different, and it tends to drag down much faster than the ISS. So
Ah,
keeping it in orbit, you have to spend propellant, not every day, but probably once a week or something like that. You have to run the thrusters to keep it in the orbit that you want it in. And so over a period of time, that amount of propellant really builds up. So if you just let it go, it slowly starts working its way down and crossing the orbits of other spacecraft and other satellites and so on, becomes a hazard. And so
okay.
if you're finished with it and not going to use it anymore and don't want to pump any more propellant into it, the best thing to do is very quickly deorbit it.
So it'd be really costly to keep it. I mean, would there be a point where it could stay in orbit without needing to boost it? And are you going to have that kind of an issue with Voyager? Are you going to have to
oh, yeah,
reboost it every so
yeah,
often?
And anything in low Earth orbit, you have to do those boost burns. Yeah,
Okay.
but beyond just that aspect of it, and really the fuel, because gravity ring has such low mass, the fuel requirements aren't significant, but you
Okay.
have to account for that in your mission profile. You have to make sure there's enough fuel there. In addition to that, if some organization wanted to do a long-term mission, let's say they wanted to do a 6-month study of a plant and how it grows or something like that,
Yeah.
you have to have people monitoring, and there's a ground control side to that as well. So that also kind of lends to the case of selling it, let someone else manage all that, where we don't really want to get in the operation of gravity ring long term. That's not our business model.
Yeah.
But yeah, somebody else wanted to take that over, and like NASA, for example, there could be potentially an interest in putting a habitat on there and doing a 1-year mission where we've got Scott Kelly as an example of a year in space and microgravity. Let's have a
Right.
4-person crew put them in low gravity and see what happens there.
Yeah.
So
Yeah.
we would hand over the station in that situation to NASA. They would have to deal with mission control and the orbital boosts and all of that, and resupplying and all that.
To accommodate such things, we're in the initial design phases right now of these propulsion modules that we'll use on the gravity ring, and we're talking about building them such that they're refuelable. The technology is not well developed. There has been one demonstrator, a U.S. mission that demonstrated transfer of fuels from one tank to another, and in zero G, it's not straightforward, but we are looking at designing these things so that if you need to, you derotate the station, you spin it down, then you can bring in a spacecraft that docks with it and refuels the propulsion modules, and then you're ready to start up again.
Wow. Very awesome. I just want to say thank you both, seriously, for joining us. It's already been it's been an hour and 15. We don't normally at about an hour I stop to do super chats, but we were just kind of going off on, and it was a fantastic conversation. I'm going to read some super chats, probably some random questions from some of the viewers.
Yeah, go for it.
But thank you very much for joining me. I love this kind of stuff. I look forward to seeing all of this come to fruition, it really feels like I grew up, I was born in early 80s, and I was obsessed with Star Trek, and I love space, and I'm now, becoming an adult, and I'm watching it actually happen in front of me, and it's incredible to witness. So it is always a pleasure to have, um, gentlemen like yourselves on my show. So thank you very much.
It's been a pleasure for us as well, Adam. And of course, we share your enthusiasm, and we're always just thrilled to meet people who share that enthusiasm.
Well, it's my pleasure. Let's see. The Great Gamers says, what do you think will happen to Space Force if Joe Biden manages to steal the election? I think the Space Force is going to be a thing no matter what. I mean, this is just my view on it. We kind of mentioned it earlier. It's the money is in government right now in space, and China and Russia are not coming to the Artemis Accords. China specifically is very much doing its own thing in space. There's this whole argument with gray water versus brown water. Are you familiar with this?
Yeah.
I'm sure. Yeah, I'm sure. Not a surprise. But for those who don't, it's essentially brown water is, within our closer, orbit, all the way out to maybe lunar orbit. But then as soon as you get outside, it's blue water. It's more like exploring and a little more science oriented, where brown water is more military, maintaining security. So there's this whole battle going on with that. And I don't think that's going away. Whoever becomes president, even moving forward, 4 years, 8 years, 12 years from now, I think that's always going to be a thing. Hopefully not. I would love world peace. That would be fantastic if we truly started working together.
Yeah, well, I'll just chime in on that as well. I think
Sure.
from just a policy standpoint, it's unusual for administrations to get rid of agencies or departments. They
Right.
might change the directive and the focus.
Okay.
So I think Space Force, like it or not, it's here to stay. But
Agreed.
its mission and what it's asked to do, I think that's where we might see some policy changes.
Yeah. See, Lucas says, I didn't get a notification about the stream, but got on as soon as I saw you were live. I appreciate all of the effort you are putting in. Thank you, Lucas. I appreciate that. Yeah, I don't know. I'm using StreamYard, so maybe it has something to do with that. Who knows? Robert Wild says, look how the improvements to artificial limbs will be improved at faster rate once we move to space. My fake leg I got now would be outdated. Be blessed. Thank you, Robert. Yeah, who knows? And would you even need it? Because I mean, artificial gravity, you probably would, but if you're going to a space station where it's really not that hard to move around, you might not need that advanced of an artificial limb if you're able to move around significantly easier. If in 1/6 gravity, you're not putting as much strain on your legs, so it's probably a lot easier to move around, right? I mean, who knows? Let's see. Carnell says, hey, Adam, with all of this talk about mankind moving towards living in space, has me thinking about one question. Do you think we will ever have space realtors in the future? Inquiring minds want to know.
Yeah, so I actually touched on that.
Tim, you want to take this?
Yeah, I think so.
I agree.
You're going to be having real estate on the moon, real estate on Mars. We're building stations. We're going to have for sure. I mean, just internally, we need somebody to sell that real estate and lease it. So yeah, we're definitely going to have space realtors. Yeah.
Now that makes me question something. Who owns the moon right now?
Whoever gets there first. So
is that it? Is that how it works?
So, well,
it depends on whether you're a signatory to the space treaty or not.
Right.
Yeah.
That's a good point.
But yeah, per the treaty, nobody owns the moon, but there's the Artemis Accords allow for utilization of the resources. But
if you sign it.
If you sign it, you're right. And from what I can tell, from what the Chinese Space Administration has said, is if they get there, they own it.
Yeah. And they're going. They're on their way. So we'll see how that turns out. Miraculous Ladybug. Hey, what's good, Miraculous Ladybug? How you doing? This was fascinating to hear. Very cool. Thanks for the fresh breath of fresh air. Love the show as always. Smash that like button, everybody. Thank you, Ladybug. You're always a pleasure to see. I appreciate that. And if you guys don't mind telling my audience to smash that like button, I'd appreciate it.
Hit the like button. Yeah.
No,
Yes,
not just hit it.
Hit the button.
You must smash
Smash
it.
the like button. Yes.
Smash the like button. You see the like button behind me? It's in a constant state of smash. Thank you. And I see that. Is that the Saturn V rocket behind you, Tom? Is that Saturn V?
That actually is a one of a kind in the world. That started
Oh.
out as an industries kit, but that wasn't good enough for me. I modified it so that it's a 3-stage model rocket with the stage separations in the scale places and electrical upper stage ignition.
Wow. Well, that's cool. I've been admiring it throughout the show. I had to ask you about it. That's pretty cool. Very cool.
I'll have to send you a picture of it coming off the pad.
All right. I'll happily, and you know what? It'll be in my studio. I'll find a nice spot for it because that would be really cool. All right. Let's see. Rachel says, this was so much fun. Thank you. Imagine when we actually get to go, when I go do an episode on Voyager Station, because that's going to be a thing. I'm going to have to do a whole docuseries about it. I can't wait. White Lasagna says, talking about zoning laws? Boring. Talk about zoning laws in space? Now you've got my attention. But for real, more interested than you'd think. I mean, it is going to be a thing, though. It's going to be a thing. Those zoning laws exist for a reason. I actually worked in trades for a long time. My dad owned his own heating and air conditioning business, so I kind of have an idea of how important trades are in general. Building laws and zoning issues and that whole thing. It could be a headache, but it makes sense because we live in houses that you would want them to be sound, and of course it's going to be a part of its space.
Mm-hmm.
So well, we're going to need something like zoning laws for orbits. They're kind of like you go out on a highway and you've got the side stripes and you've got the center stripes and so on that you're not supposed to cross. Well, we'll have the same kind of things, not painted in the sky, but there will be orbits where you're assigned to this orbit. This is your lane. Don't get out of your lane.
Or it would mess up. I mean, a piece of sand, right, could mess up an entire station. Right.
We're designing it such that we're designing our station such that they handle more than that. The ISS can handle something that's more than half an inch across of solid aluminum hitting it. In most places, they have what they call Whipple shields for the walls that will handle that. But if a spacecraft has lost its radio antenna, and that radio antenna is uncontrollably in orbit, and it hits you, it is, as I say, distinctly suboptimal.
Yeah. That's good.
Yeah, that Whipple shielding, Adam,
things that they're going to have to do to make sure that when you get your spacecraft up there, when you're done with it, you have to do something to make sure it's not going to be a hazard to everybody else.
Right.
Yeah, and that Whipple shielding, Adam, is similar to how a bulletproof vest works, right? It can handle up to a certain caliber and you're fine. But if you get run over by a tank, you're going to feel it.
Right. Yeah, it's not going to stop a tank running you over. Nani says, spin the UFO for the future of humans in space. All right, I will do that for you, Noni, right now. I don't know if you could see my little UFO I have here, but I'm currently spinning it. Shun says, why the F YouTube flagged this as flat Earth? Really? YouTube flagged this video as flat? I don't understand that. That's weird. There is a Wikipedia article under my video on mobile. No wonder it's shadow banned. False flagging. That is weird. We're talking about space. Nobody here thinks that Earth is flat. I don't understand why they're fact checking my video. Oh, well, there's nothing I can do.
I don't think we even said the word flat. This is the first time you said it.
This was it. Yeah. First time I've. Oh, my name is blocking the UFO. I'm gonna just take over real quick. There, you could proof that the UFO is spinning. All right, I just needed to bring proof to everybody. Okay, so we are out of time, gentlemen. why don't you tell everybody how they can follow you, find more of your work? I'll give you both, a minute to just, tell the audience how to find you and, hear more about what you're doing. Um,
Yeah.
Tim,
So
Tom,
right
Tim.
right
Okay.
now, the places to go would be to go to VoyagerStation.com and OrbitalAssembly.com, and that's where we're going to be posting updates. We actually have a lot of exciting new things coming up that we're going to be announcing in the short term. Also, Gateway Foundation. If you Google them and find the YouTube channel and the website, you can join for free. There's a mailing list, and most of our announcements go out to the Gateway Foundation. So those are the places to follow us and keep up to date.
Excellent. Go ahead, Tom.
And I don't have a whole lot to add to what Tim said.
Yeah.
He summarized it quite well there. Just stay in touch. As he said, there are going to be some very exciting things coming up soon.
You guys finished the show with talking about how exciting stuff's going to come on. Like, now I want to know. I want to know about these exciting
We
things.
can't talk about it. That's why we didn't mention it previously.
I'll just have to have you guys come back on and we'll talk about those exciting things. And I actually, in the description below, you guys can actually click on, I have the team at the Gateway Foundation, the website. It shows everyone on the team. Of course, these two guys are there. So you can find out more about them, about their background. It's really interesting. Gentlemen, thank you so much for joining me. What a fantastic show. I can't wait to have you guys on again. We should
Thanks for having
continue
us.
doing this. Definitely.
It was a pleasure,
thank you.
Adam. Thank you.
Thank you very much. And everyone who is here, thank you for joining me. Tomorrow, I will be back. 6:30, Carlin Borisenko is going to be joining me. We're going to be talking about all the stuff that's been going on this week. Lots going on this week, and it's going to be a great episode. So thank you very much. I will see you all tomorrow. Have a great night.